useful. So I'm going to create the entity, but I've noticed I've broken the first rule of TDD, which is we should not write any production code before we write a test. So I'm actually breaking some rule here. So I would encourage you to visit, there's this Uncle Bob article on TDD. It's very popular, the cycles of clean code. And in this, Robert Martins goes into a lot of details into how to do TDD, but most importantly introduces these 3 rules, the rules of test-driven development. And rule number 1 is, okay, I lost it. Rule number 1 is, so create a unit test that fails, write production code that makes that test pass, and then clean up the mess you just made. I noticed he has simplified these rules. Yeah, but the main point is you don't write any production code before you've written a test that fails. So we're going to start by writing a test that fails. And the way we do that is, in fact, I was the test directory. This is the test folder, this is the main. So this is where we were supposed to declare this movie, in fact. So I'm going to rename that into movie persistence test. And this is how we are going to test the persistence of the movie object. Persistence. So this won't be an entity. Instead, it will be a test. And the way we mark it is we'll say this is a data JPA test. So this is the annotation that we use to annotate persistence layer tests within Spring. Then I'll be using JUnit, but I need JUnit to be aware of Spring. So to do that, we'll need to use this annotation called extends with. And it extends with Spring extension.class, Spring extension. So what happens here is using extends with tells Spring that this test will require, it basically tells JUnit that this test will require a Spring application context, and the Spring extension will handle bringing that Spring application context, or at least making it available for the test. Then we'll have a simple test function here, and this will be should persist movie test. So this test will ensure that the movie is actually stored in the database, whichever database format we're using, as long as the other components are not broken. So of course I'll annotate it with the test notation, and this is from JUnit, JUnit 5. That's why it has that Jupyter in the package structure. And to make this test successful, I'll need to bring in a few things and be using something related to the IOC concept that I talked about. This is that auto-wired annotation. So auto-wired annotation does dependency injection. It injects a singleton instance of the object I need. And the object I need for this is a test entity manager. So this test entity manager handles the, so if you look at the Spring Data JPA specification, you'll notice there's this concept of an entity manager. So this will bring in a entity manager specifically designed for running integration tests, or you might also call them unit tests. So alternative to entity manager for using JPA tests provides a subset of entity manager methods that are useful for test, as well as helper functions for common test tasks such as persistent flash. So when you're running a test, the data that you store should not have a long lifespan. In fact, if you are persisting any objects in the database, they will live only as long as that test function is active. So once you exit the test function, if you exit this, the object should be removed from the database. So Test Entity Manager gives you functions to allow you to do that. One of them is flash. So flash will clear everything that you've stored in the database, so that when you're running the next test function, you're sort of starting afresh. So that becomes very helpful, and it allows you not to have to set up your own before and after cleanup functions. Normally, what you would do with the regular test is you'd have this before each annotation and have a function there like setup, and setup will, for instance, initialize init the DB, and then at the end of all the tests, every test function will have after each, and after each allows you to do cleanup. So cleanup. So here you might decide to delete everything from the database and start afresh. At least start afresh in terms of when the next function begins, let it start with a clean database. But with the test entity manager, we don't have to do this extra work. So essentially, that's what it saves us from. Okay, so for this to work, we'll do maybe three things. First, we'll create an instance of movie. Then the second thing we'll do here is we will persist the movie. Then we will check if movie is persisted. So we'll check whether it's stored, and then we will end this function. So it's just three things we need to do. So I'll go ahead and make a movie. So maybe this movie can have an actual name like Tenet movie, and it will be an instance of movie. And we know that movie has three properties. It has ID, which is a long, so I'll use 1L. It has a name. In this case, the name of the movie is Tenet. Then it has a release date. I can't remember when Tenet was released, but I'm just going ahead to guess. So we'll say it's maybe 2021. I think it was around that time. And we can guess the rest of the values for this. So that will be the release date, that will be the ID and the name. So ID, name, and release date. So those should be the values. So once we have this Tenet movie, which we can see we already have errors here, following the rules of TDD, once we see that our test is failing, because if we try to execute this test, of course, we'll get a failure. So once we see that our test is failing, the next thing we will do is we are going to write production code. So now we are permitted to write production code. So we must write a failing test before you write any production code. That's rule number one. The rule number two is you must not write more of a test than is sufficient to fail. So once it fails, don't go ahead writing the test. And also you should not write more production code than is sufficient to make the failing test pass. So those are the rules. So we are going to go ahead and create our movie. Since we don't have one, we need to create a movie entity. Call this movie. It's just a regular class, and we should not do anything extra here. Just enough to make this work. Of course, it has some fields. We have an ID here that's long ID. It has a name, which is string name, and we have the release date, which is local date. Release date. There we go. So we have the fields, but we need that constructor. So we'll go ahead and employ Lombok services here. So I'll bring an all-lags constructor from Lombok. Yeah, I'm preventing myself from writing any additional code than we need for the test. So now if we run the test, enable annotation processing, you see we still have a test failure. Let's see what's causing the test failure. So the cause of the failure is data source. So we haven't configured the data source for persistence. So when we try to initialize Spring Data JPA, we'll get a problem. So what we need to do is we need to have the data source configured in application.properties before we can move ahead. So I'm going to go to, so you can have two actually. So within your test, you can have a resource folder, directory resources, and here you can have your application properties for testing, application.properties. So this will be for your tests, and for the production code, you can create a file right under resources, call it application.properties. Okay, so it's seeing that we already have this here. So we could rename it to something else, though I was expecting it would allow us to have that. So we can call that test.application.properties. And here we can have the main application.properties. Oh, okay, it actually already exists. So when we're initializing Spring, when we went to start.spring.io, which I already closed. So when you go to start.spring.io, when we initialize the project here, it already added an application.properties file for us, which has the application name. So we don't have to do that extra work. So now we need to configure the data source. So I think the key is spring.data source. And here we'll just tell it which, we'll just point it to MySQL. Let me just see if I can find a preset config for that. Spring data source key. So the key we are looking for is spring.data source. Yeah, so spring.data source, I think we don't need the data prefix. Just need to specify the URL, and this will be MySQL. We start with JDBC and MySQL, localhost 3306. And the database name, let's say we're working with a films database. I think that should do it. Let me just make sure. So yeah, so data source.url. So this one is h2. Oh yeah, we need to specify the username and maybe the password for that data source. Since we are using MySQL, that will be, so I just have a default setup of MySQL. So this will be root and spring.datasource.password, and this will be empty. I think that should do it. We don't need to set up connection pooling, JDBC, MySQL, localhost test. Yeah, that should be it. Wait, I don't even need to specify the port number. Okay, I didn't know that. So we have the username, we have the password. I'll skip connection pooling. This is just a demo application. We don't need to take it that far. So let's see if our test is able to execute. So now you see the importance of TDD. It allows you to catch even some of the some components that you might not necessarily pick up on, at least on the start. Because I was expecting that the data source will be preset, will be configured. So that's interesting. Okay, so you see that the test is still failing. So let's see what is the reason for the failure this time. So found required class javax.sql data source. Embedded. Oh yeah. So there's something we forgot to do. Since we are writing integration tests for our application, we need an in-memory database to serve as our target for database level tests. And for that, there's an in-memory database that we use. It's called H2. H2 in-memory database. So we need H2, and H2 allows you to have an in-memory DB. You can also do this with SQLite. SQLite also supports in-memory persistence, but Spring has H2 support out of the box, so you don't have to do additional configuration to work with H2. So that will help us with that. So that it doesn't become something that we need to worry about. So the way we bring in H2 is we're supposed to bring it on the onset. We're setting up the application is start to spring.io, but we can still bring it in later. We just need to see which part of the POM file we'll need to edit. So the bit we don't have is this part, which brings in the H2 dependency. So I'll just copy that and I'll bring it into our POM file. So just on the dependencies, I'll just add it at a good spot. Like since we're using it for tests, perhaps this would be a good spot to add it. So this brings in H2. And as long as we have it there, we should be good. Let me run my event clean install once more, just to make sure that we have the package. So Maven will be responsible for pulling the actual package into our project. So that's what's great about Maven. And now, since we have H2, I don't think I'll need to do additional configuration for this. Let me see how we do. Nice. So H2 has handled the data source issue that we were having, but it also forced us to set up the production level persistence. So at least now we know we have a persistence for the production application with the MySQL. But when it comes to the test, we don't need to provide anything here because H2 is handling it. So H2 handles test level persistence. So our test is passing, which means we can go ahead and write some more production code, a test code. So when your tests are passing, you write more test code so that you have a failing test, and that would give you the license to write your next unit test. So let's go ahead and add the next phase. So we've created an instance of movie. The next thing we are doing is we are going to persist the movie. So to persist it, we are going to use the test entity manager. So I'll call test entity manager, and I'll call, so this persist. So this just saves the object into the database, and you can run additional testing after. There's persist and flash, which persists the object gets that instance of the entity, whichever value was in that database table row, and once it returns that value, it clears the database. So this is usually the most preferred, especially if you're just testing persistence, because once it's called, you'll get back a valid instance of an entity. If nothing was saved, you won't get back anything. So that's what makes it special. So make an instance managed and persisted, then synchronize the persistence context to the underlying database. So delegates to entity manager, persist, then it calls flash, and finally returns the original source entity. So this is really nice. So it actually does the actual save on the database, but it returns the actual value on the row, and once that value has been returned, it clears the database. So you don't have to do that cleanup work on your own. So that's super nice, I think. So I'll just go back to the test here. And to call it, we'll just pass in the entity you want to persist. In this case, it's the Tenet movie. And like we said, once it's done, it should give us an entity. So once we have an entity, now we can start doing some comparisons here, or verifications. And to do verifications, I prefer to use this library called AssertJ. AssertJ it's not very different from default assertions that come with JUnit, but I like the syntax. I prefer the syntax of JUnit. It feels more flexible. So you get this assert that, and you can pass in what you want to assert, and you can use different versions on the other side of this. So you can do equal to, you can do not null, you can do is empty, and also it's type sensitive. So if you're checking like a double, you can check for size is greater than, is less than. Just makes it really nice. And also there's additional chaining that you can do with it, which is really, really good. So we're going to use AssertJ. So I'm going to import that assertion. So I'll do a static import, AssertJ. Let me import the specific function, assert that, AssertJ. Okay, it's not doing it automatically. I was hoping the ID would help me with this. Let's see. Okay, so we are going to org.assertj core, then so there's API, there's condition. So one advantage of doing these imports on your own, it allows you to explore the API also, so that your knowledge of the API is not limited to only the functions that you use. So assertions, I think this is where we'll find assert that. Okay, so this is what we are using. So assert that entity, our entity is not null. So once it's pulled from H2, it's not null. We can also check that our entity has the properties we expect. So for instance, the name, entity dot, so get, we need a get name here to check the name. Is not, maybe it's not empty, but you see we don't have get name. So if we try to run our test, it will fail. So now we have license to go to the production code and start messing around with it. So what we need is getters and setters. So I'll use Lombok, which will give us getters, and also have it give us setters, so that we can proceed. So get, that will handle get name, and we check that get is not empty, the name is not empty, and we can now check the next property, like the release date, and since this is an object, we can check that it's not null, and we can also assert that entity dot id, get id, which is long. First of all, is not null. And we can also match the actual values for these properties, like entity.getName. We can ensure that that name is tenet. So dot is equal to name, referring to this variable. And we can also check the release date. Assert that entity.get release date dot is equal to. So here we can utilize some function that's available in local date that gets the temporal value for the date and checks it against another temporal value. So we can call release date, which is the value we used for persistence. And here we can check, check that this is true, that they are actually equal. So get release date is equal to that, should give us true. Then we can check the ID for fun, such that entity. I'm saying for fun because some interesting things might happen with the ID, but we'll be able to explore that. Is equal to ID. Okay, so we have a good test here. Let's run it. Okay, so our test fails as expected. So movie is not annotated with entity. So we need to have the entity annotation on the movie to make it an actual entity. Otherwise, test entity manager will not persist it. Back to the component scanning issue that I mentioned earlier. When component scanning is done and this annotation is not present on this class, Spring will skip it and it will be added to as a bin to the application context, which means Hibernate will not discover it, which means JPA will not, it will not be used as a JPA entity. So it's important to have that. Otherwise, of course, the application will not function if you don't have that. So just looking at our checklist, we've created the movie, we've persisted the movie, we've checked if movie is persisted, we've checked if the movie is persisted, and that should be it. So now if this test passes, we are good with persistence. So now let's move on to other things, which is getting the test to actually work. So I've added the test entity annotation to it. So I just want to see if that fixes everything for us now. Okay, so that doesn't fix everything. Instead, let me just make sure we know exactly why the test is failing. So no named parameter. It's always good to read these error messages so that you also understand, because I have a guess as to what went wrong, but it's also good to see how Spring reacts when you miss something. So it's very long. Let me see if I can get something more specific. Unconditional class, exclusion none. So transaction auto-configure did not match. Did not find required class. Okay, something to do with Tomcat, but we are testing persistence, so that should not be an issue we should worry about at this time. Instead, let me just kill this for a bit so that I have more space. So instead, okay, so transaction manager, okay, that brings us to something we are familiar with. Did not find any beans. Okay, JDBC template. Okay, again, still referring to data source. And so it looks like we didn't set up our movie entity correctly. And I can already guess that the thing that's causing problems is the lack of primary key. So let me attempt to do that. So we'll have a primary key by adding the @id annotation. That's from Jakarta persistence. And that @id annotation, we can have this ID be generated. So that it's auto-generated, and we can give a Spring Boot a strategy for generating it. I'll use identity for it, generation type identity. And let's see if that solves our problem. Okay, so test is still failing. Detached entity passed to persist. So yeah, so this is why I said things would get a bit interesting. So when you see this detached entity passed to persist, it refers to a conflict. You have a stale object. So you have an object that it's within the transaction, but it seems like the object was not properly persisted. And also we are trying to reference properties that are inside that object. And the way you deal with that within Spring Data JPA test is you set the initial ID to null, so that when the ID is generated here, you won't have a conflict. Because JPA is trying to generate the ID, but also we are passing the ID ourselves. So that causes that detached entity error that you saw there. So detached entity pass to persist. So whenever you see this, just remember whenever you have a generated ID and you're trying to use it in a test, Spring Data JPA won't be happy with that. So it's good to pass in null at least at the onset. And it's just limited to the test alone. So when we do that, it means, of course, the ID will be a correct ID and it won't be null because we are trying to check whether the ID is null. So in real sense, we won't know what the ID will be because it's being generated. So it's good to not check the ID for an actual value. You can just check that it's not null. And now if we run our test, we'll see that we are good. The test passes. So we're able to persist movie. So going back to our checklist of things we are supposed to do, persistence is done. So persistence is not an issue that we are working on. So we've managed to get that, but there's a problem because persistence is multi-layered. So we have the entity layer, and we have a repository. We need a repository so that the service layer will not be creating its own entity manager and trying to do database transactions directly. Instead, it can use the repository pattern, which is way more convenient. So we've finished this. We've finished that, but we haven't finished this. So this is still pending. So what we're going to do is we're going to work on the repository layer and get that done, hopefully. And the way we do that, of course, we need to begin with a test. So I'll create a test. I'll call it movie repository test. And this movie repository test, just like the other test, will be a data JPA test because it's testing the persistence layer. The advantage of using this specific annotation, it limits the test to persistence. It limits the test to Spring Data JPA. So it doesn't try to load your services. It doesn't try to load your controllers. It will only load your entities and your repositories. So that's why this is super important to use. So, and when you do that, your tests execute faster than they normally would. And of course, I'll try to let JUnit know about the nature of our test, that letting it know that we're using a Spring application context, which will have the factory bin and will need the dependency injection and all that. So this is just a communication to JUnit. You can see the annotation is from JUnit, and we are passing this Spring extension to it. So for this test to work, we'll just do a simple, maybe we can do two simple JPA repository layer operations, which is to save and to retrieve. So here we'll test that we should be able to save a movie test. And so that will be the first test. The second test we'll do is we should be able to retrieve. That will be our second test. And maybe we can do the CRUD cycle and should delete movie test. And this will test our ability to delete the movie. So let's go ahead and handle the saving part. So I'll bring in, just like in the other case, we'll need to auto-wire the repository that we still haven't created. So movie repository, since we are not using test entity manager here, we'll have to have the actual repository so that we can use it for this test. So I'll just mark this with the test annotation, and it will be the first test that we do. If I run it, of course, it will fail because we don't have a repository. So I'll go to production code now. I have license to go to production code, and I'll create the movie repository. And we'll need the stereotype annotation repository. In some cases, you don't need it, especially when you extend JPA repository, but let's do a case where none of that is done yet. Again, following the rules of TDD. So just have the movie repository. And let's run our test and see if that fixes things. Okay, so we still have a problem. And the problem, I believe, is unsatisfied dependency. So error creating movie repository test. The unsatisfied dependency is repository. So this, because component scanning wasn't successful and the movie repository doesn't qualify as a bin, therefore for this to work, we need to annotate it with repository. So that will make it discoverable by Spring, and we will not get that error again. I think I might be wrong. So unsatisfied dependency, error creating a bin with the name movie repository. Unsatisfied dependency expects true field repository, not qualifying bin of available. Expected one auto-wire candidate. So that should have fixed it for us. Because if you mark it with the repository. Oh yeah, so the other thing with the Spring.JPA repositories is their interfaces. So let's see if that is what we are missing. No. That should have worked. Satisfied dependency. Oh, okay. Field repository, no qualifying bin of that type. So that should have fixed it for us. So we'll take it a step further. So do this until the test passes, and we'll say this extends JPA repository. And with JPA repository, you can pass two things. You'll configure the type of entity, and you'll configure the type of ID. This just tells Spring.JPA the types, not necessarily the values. So the entity here is movie, and the type of our ID is long. So again, this is why it's perhaps important to use object type for long, because generics doesn't support primitive types, but also probably JPA has some way of addressing that boxing issue, so that if you are, the ID of your entity is a primitive type, it will be able to map it to an object type without you having to change the signature of your entity. So that might not be such a big problem. So I'll run our test again. Okay, so looks like it wanted us to extend JPA repository. So you make it an interface, and then you extend JPA repository, you pass in the entity and the ID type, and you're good. So then we'll do the next step, which is to use the repository to persist. So first, let's do some planning. So the first thing we'll do is, of course, create a movie instance. Then we will persist that movie, this time using the repository instead of the test entity manager. And then we will validate the movie that we get. So I'll create a movie. It's equals to new movie. And the properties of the movie, of course, the ID, the name. This one is pressure, just came out. And release date, let me make this separate. Release, which is the release date. I'll use local date, of course, of maybe, so it's 2026. And probably came out in February, somewhere the beginning of February. Yeah, that's the release date. So let's make sure that we can do that. So I'll just run the test. Okay, the test passes. This is pressure. Then we'll use the repository to save. So the good thing with the repository, comes with these inbuilt functions, save, retrieve, all of that. So we'll save the movie. And when you call save, it returns back the persisted object, just like persistent flash, except it doesn't do the flash bit. Saves a given entity, use the returned instance for further operations, as the save operation might have changed the entity instance completely. So to return the entity to save must not be null. Or you pass in the entity, which must not be null, and then returns the saved entity. Yeah. So now we can go back, and so this will give us the entity that we saved, our entity, and we can do some assertions on it. We can assert that the entity that's returned is not null. Of course, that means we again need to import AssertJ. This time I'll use this shorthand to try and get it in quicker. Assert that. And we can assert that it's not null. Just like the other case, we can check some of the properties, like the name. We can check that it's equal to the name we are using here, which is pressure. We can assert that the entity release date is the same as the one we used. And we might also check the ID. So we might get some surprises when it comes to the ID. So I'll just check that it's equal to 1L, which is 1 long. Okay, so our test is failing, and let's see why it's failing. Object optimistic locking failure. Row was already updated or deleted by another transaction for entity. Yeah, so this could still be related to the ID thing. So let's change it to null so that we allow Spring to set up its own ID. And since it's null, I don't know what Spring will generate for the ID, so I won't have an assertion for the value of the ID. We can just check if the ID is not null. So although I've seen the test as passed, let me just add this so that we don't completely neglect the ID. At least we check that it's not null. Java being type safe, I won't need to check that it's long, so that's nice. So yeah, so that passes. So we know our repository, at least the save function of our repository works. So we can test other functions. So to test retrieval, we'll need to save a movie first. So I'll reuse some of the code we have here. And yeah, just check that it's not null. What did I do? Okay. So so for this test, at least the setup phase will be to persist that movie. And the function we are testing is this retrieval. So let me call this movie from, what will we do? Yeah. Because we're able to get the entity once save happens, but we want to make sure that we get the same entity when we call retrieve from the repository itself. So let me call this saved entity, and we'll call repository dot find. So there's multiple find functions. We'll use find by ID. Yeah. And we can use whichever ID has been set up for this entity. Since we passed in null, we know there will be an ID value. To be sure of that, we can actually log that ID. I think Lombok comes with some inbuilt annotations for logging. So yeah, so you can use that. So it will look for a logger in the class path and utilize it, either log4j or one of those. Does the automatic setup for you, so that's kind of nice. So you can do log, I think it's just log, yeah. Or if you just call log and pass it a string. Maybe it's, yeah, it's log dot log, and yeah, I think just pass in the text. Do you need to pass in any other? But let me just check the signature for this. Yeah, just receives the topic, which is default. So yeah, I want to log the entity ID. Entity.id. Method call expected. Okay. Looks like I've forgotten how to use as a Lombok's log function. I'll just check that. So oh yeah, okay, you pass in, you use the level of logging. So you can do log.info, but it's conflicting with something here. It's conflicting with something in my class path, because this should work. I'll pass in the log message. That should have been okay. Okay. So it's log.info. Okay. Yeah, otherwise I'm referring to the annotation directly. Okay, so we want to log the entity ID, and as I think I might have forgotten the signature here. I think you use something like something like that. Okay, we could also just concat it, but I think there's some fancy way of referencing the attributes so that you don't have to concat. But anyway, that's not the main event. So we get the entity ID. So I'm just logging that just to make sure we got an entity ID generated here. And now we can do some assertions on the saved entity. Save entity. We can check that it's not null. We can also check the save entity for some properties like the name. Oh yeah, another thing is the find ID returns an optional. So since it's optional, we might need to unwrap it first. So we get an optional save entity. So if optional dot is present, then the rest of our code can proceed. There could be a better way to write this, but just use that. So if present, then we'll have our save entity, and we'll retrieve it from the optional by calling get. And once we have it, we can check for some properties. You can check the name is equal to pressure, and we can check the release date, and we can check that it's equal to the release date that we used. And, let's see. So it's true. So those should be the same. So to validate this optional, we can add an additional assertion here for optional.isPresent. So this will check the optional and ensure that there's actually a value. And the ID is also detected that, which the suggestion here is we might not need to have the if statement. Since our assertion will have already checked, we can do a dangerous get. So what get does is, if the optional is empty, it will return null. But since we've already validated that it has a value, if this assertion works, then we don't expect this to be null in line 34. I forgot to annotate this with @test. So now it's annotated. Yeah, and we see that that works. So since I've seen JPA is working, I don't need to test those internal methods any further. So if we go back to our task list, you'll see that now the repository is working. So now we can go to the service layer, and in the service layer,